Hello everyone and welcome to Grantham Physics 221 Week 7 Lab 7 video. Remember when we work on this to always observe the lab report format, and if at any time you have any questions, please talk to your instructor. So radioactive decay is a very useful tool in physics and has many real-world applications. So what you're going to do this week is look at a plot of a radioactive decay and determine timelines and eventually the isotope in the question. So what you have here is a situation where you have the particle number versus time in years. The particle number is on the time is on the y-axis. It's always on x-axis. It's always on the x-axis, and the particle number is on the y. So the sample started with 1,000 particles on the y-axis and with time on the x-axis. Determine the half-life of this isotope using the equation n equals n0 e to the minus t over tau. And what I'm going to do here is zoom in because it's really hard to see some of these exponents. There we go. So what you're going to do this week is you're going to examine this and determine these questions. Determine the half-life of this isotope using the equation n equals n0 e to the minus t over tau. So you have to actually look at the graph and determine a few different properties. For example, where the 1/2 comes in. Notice it starts with 1,000 and it goes to 1/2, and that corresponds to a certain time. Is that going to mean something in particular here? So again, using this equation, how do you figure that out? Determine how many particles are present at 4,000, 6,000, 8,000, and 10,000 years using the graph. Remember the graph here, it's time in years on the x-axis, number of particles on the y. So you should be able to interpret this, and it is going to be a little difficult at times. That's why I chose some of those, so it's not something straightforward. So what are some applications of an isotope like this? Once you can figure out what this is, it's kind of tied together. Once you have the half-life, what do you think the isotope is? You may want to try and figure out some uses, I've picked a pretty specific isotope here, and you should be able to find some values. So let's take a look at the first step. If n equals n0, and again, a real close-up, minus t over tau, where tau is the half-life. How do we get some information out of this? How do we figure out what's going on? Okay. Look at the values at 1,000, and look at the values at 500, and so on and so forth, and see what you can calculate. Does this mean exactly how fast things are going to fall off, how fast things are going to rise with time? Look for connections and do it graphically. See if you can, again, find this relationship here. Here's 500, here's roughly 250, and then solve the equation manually also and see what this comes up with for each specific situation. Okay, well, that basically kind of covers what I'm doing here. I hope you are able to figure this out. Again, if you have any questions, please feel free to send your instructor an email. And again, at all times, always observe the correct format for doing the lab reports. I wish you the best of luck and see you next week.